Good morning. We are getting started. Everyone should have watched the videos for 2, 5, 2, 6, 2, 7, I believe. So this is the end of what we're going to do for the first test, which will be next Thursday. I'm going to do that one in class, unless everybody wants class time to ask for help and then take it in the testing center. I guess I'll let everybody send me emails and kind of vote on that. That's an option. I'm okay with that too. Since Tuesday, I haven't, there's no classes, it's all in service days. So I can do a Zoom with everybody on Monday or Wednesday if you want, or you can send me questions, but I will have a review out there for everybody to work on that I'm happy to record answers to and all that good stuff. Okay. So how about I share my screen? Other said number 9 on. This is a company that manufactures ink cartridges for printers find that they can sell X cartridges each week at a price of P dollars. So P is changing inside this equation and it's affecting X. What price should they charge for each cartridge if they want to sell at least 400 cartridges a week? So first thing I would do is, I'm not going to solve this one because it's part of your homework, but I'm going to get you going and then I'm going to go and do another one that would be similar. So I would always kind of rewrite the equation just so it's kind of separated out and not within that story. And then it says, I'd go back to the question, what price? So P is the question, right? What price, what should they charge for each cartridge if they want to sell at least greater than or equal to 400 is the X. Okay, so they want, X is going to be 400 and they want 400 or more. Okay, so at least 400. Okay, 1300 minus 100 P. I'll make sure we have this set up correctly here. We want X to be 400 or more. So I'll put in, let's just see here. Okay. And it's P dollars. This is how much they're selling them for. Okay. So the more that the more that they sell them for, it goes down because that's what this negative 100 tells us, which we're going to talk about the pieces of a linear equation later. So let's go to, how about we go in our book here and we'll pick one that gives us a good equation. Did I do any in the notes? Let's do 38. I love talking about weddings. So 38 says, for a wedding reception, you wish to rent a hall for 150 guests. Your budget, including hall rental fees and food charges, cannot exceed $6,500. Set up and solve an inequality to find the highest cost per person for food to budget for at a venue if typical hall rental costs are $2,000. Okay. Okay, so we are going to have, let's see, equal our cost per person. And we know we're going to have 150 guests. So we're going to have 150 times the cost per person, right? And they said, we're going to have a fixed cost, which a fixed cost means something that you have to pay no matter what, right? Even if you have one person come or 300 people come. And they said that that fixed cost is $2,000. And they want it to be this to be less than or equal to $6,500. That's why I think this actually should be greater than or equal to. I think this might need to be greater than or equal to now that I think about it. Because we want X to be greater than or equal to whatever P is over here. Because it says they want to sell at least 400 cartridges. I'm pretty sure that needs to be greater than or equal to. I'll let you know if that's not correct. So we want our cost per person to be less than this whole cost thing to be less than or equal to $6,500. So any questions so far? Kind of how we have it set up now. On the one on 9 and 10, they gave you the formula. So that's a great thing. So we are going to solve for C. And so when we solve for C, we're going to subtract our, first, we're going to look to see if there's any fractions. No. If there's any parentheses, no. And that's going through all of our lists on page 110. So I keep reminding everyone, page 110, 110, 110. I would have that list because you can use, I've mentioned this a couple of times, you can use a double-sided note sheet, 8.5 by 11 on the exam with formulas and examples, strategies to yourself, that's fine, okay? There's not gonna be any factoring on my first test. So it's all gonna be some basic things from chapter 1. And I might put like one little factoring, just a factoring problem, but other than that, there's no solving for the 2.1. So the only thing from chapter 2 is just going to be solving. They're all going to be single letters with just a 1 exponent. So you don't have to worry about any of the factoring solving. So we're going to subtract 2,000 because we need to get our constants to one side. Oh, you know what? Mrs. Main always likes to get my variables to the left. Remember that? So I'm going to subtract and subtract my 150C and put that over here. Because I like to read mine. That's what's scooping me up with this is I like to read it on the left. So I'm going to have a negative 150C, and you don't have to do it the way I do. You can put your variables on the right. And then I still have plus 6,500 greater than or equal to 2,000. That means I'm going to put my constants to the right. So I'm going to subtract because I'm adding. So I have to do the opposite sign so that this adds to 0. So subtract 6,500. So we have a negative 150C greater than or equal to, and then plus 2,000 minus 6,500. Get out your calculators. Is a negative 4,500. And then our last step is always the multiplication property, which means we're going to divide by this number that's attached to C, because we want those to divide to make a 1C. And then we're going to divide by a negative 150. And also, when we divide by a negative, that's when we always circle our inequality. This is the only time on inequalities where we have to flip our sign is when we divide or multiply by a negative. So I have to flip it to be less than or equal to. Now it's 4,500 divided by a negative 150. So X is going to be less than or equal to $30 a person. To get $30 or less per person. Any questions so far? I think we did we didn't do the organic. There was one I thought with colors. Oh, there, I think there was in the other one, the story one. How about we look at 33? This will give us some more practice. So it says the fuel efficiency for cars has been increasing steadily since 1980. The formula for a car's fuel efficiency for a given car between the year 1980 and 2016 is here, where E is the miles per gallon, X is the number of years after 1980. Should I do this one on the notes? I don't have my notes right here. For some reason. Okay, I'd already done number 33, so we're going to do 31 for another. So if you didn't catch 33, that means you didn't watch the video. So I'm encouraging you to do that. So let's look at 31. It says art supplies. A store selling art supplies finds that they can sell X sketch pads at each week at a price of P dollars each, according to this formula here. What price should they charge if they want to sell at least 300 pads each week? So this is good. We're going to have an opportunity to write all four ways. Okay. So first thing we're going to do is we're going to rewrite the formula that they gave us. 31, and it's X is equal to 900 minus 300P. And so what price? So P is what they're asking us to solve for with these different restrictions. And so what price should they charge if they want to sell at least 300 pads? So they want this to be greater than or equal to 300. So we want X. So off to the side, so A is going to be, we want X to be greater than or equal to 300 pads, okay? So if X is equal to this, right, then I want this 900 minus 300P to be greater than or equal to 300. So I think we'll go back to 9 once we get this one done. So I make sure that I gear you in the right direction. Is everybody with me so far? So here's what we know is true. X equals this situation. We put P in, we multiply it by negative 300 and add it to 900. But they said they want X to be greater than or equal to 300. So what I did was I set this up, what they want us to be, they want X to be greater than or equal to 300. Then I just replaced X with this equation. And then that's how I know I've got it set up in the right inequality. So we're going to, and plus for me, right, Mrs. Main, I've got P on the left. So it's all in how you set it up. So you can set it up so your variable's on the left. So subtract 900. We have a negative 300P greater than or equal to, and we don't have to flip the sign because we're just subtracting, not multiplying or dividing. So negative 600. And now I have to divide by a negative 300 to solve for P using my multiplication property. And I'm going to circle the inequality because we have to flip it. So it's now less than or equal to. And so P is less than or equal to a negative 600 divided by negative 300 is a positive 2. So less than or equal to 2 pads each week. I'm sorry, the pads need to be $2 each. It's weird because the word is pads, right? But they use P for dollars. I like it when they use letters that represent the words. Does everybody make sense to everyone? So the P, I'm in my brain going, P is pads, P is dollars. So the cost, let's write out what it is in words. It's important that you can, because real life isn't going to be just solving equations, right? Real life is a real life scenario. So I want to make sure everybody knows how to interpret what we just talked about. So the cost of the pads needs to be $2 or less to sell at least 300 pads per week. Okay, and I'm going to show you how you can make sure that this is correct. There's numerical things. You could put a number that's less than $2 in and make sure that you get a true statement, right? So that's one way. But if you go to Desmos, I love the idea of using Desmos because this is going to really carry you through this semester, next semester, in other classes. Okay. I'm going to put in just the equation of the right side. So I'm going to say y equals, I'm just going to let it equal for now, 900 minus 300x. Okay. And I'm going to hit enter. And then we can't really see it on there. The scaling is weird. So you could zoom in and out over here to check that. Or if you click on the gear and then go to convert to table, this magnifying glass will come up and you click on that and it will actually put your graph into a scaling that works. So we said we want to know, we want the number of pads to be greater than or equal to 300. So I'm going to say we want this output to be greater than or equal to 300, right? So I'm going to say let y equals 300 for us. So I just want my output to be 300. So we're basically looking for a pivot point here. So I want to know when is my equation, when is x bigger than 300? It's not on the left, right? Because the blue is under the red here. It's to the right of this where it intersects. We want to know, we want the 300 to be above that equation. And so that means that that P has to be wait, we want 300 to be, we want this to be greater than 300. Sorry. We want this to be greater than 300. So we want it where the red is bigger. My brain is off. Their lettering is driving me crazy in this book because I would use different letters. So so we want 300 to be the very minimum, right, number of pads that they make. So we want everything to be greater than. So let's see if I can do, I don't think I can do y greater than. Oh, I can. That's awesome. So you could actually put in there y greater than or equal to. And actually, I think if you go left and we go down here to the keyboard, we can probably maybe do it greater than or equal to. Oh, duh, it's right there. There we go. So you can see where it's shaded, and that's going to be when P is less than 2. And because it's shaded and it's completely shaded in, it's not speckled, that means it's going to be an including. Okay, sorry. I wanted to figure that out because I wanted to be able to show you all that. So let's go back and make sure that that's what we have here on our paper. That's exactly what we said, was they have to keep the price at less than or $2. So this is a good time to practice our interval notation as well. So our interval notation is always the minimum that our value can be, comma, the maximum our value can be. And the minimum that our value could be is really only 0, right? Because they can't charge negative. So some of this in the stories, you have to keep it realistic. So it's going to be a bracket because it could be $0. Doesn't make sense that it would be, but it could be. So it's using a bracket, comma, 2. And it gets a bracket on the 2. It's the maximum because it's an equal to, less than or equal to. So hopefully this is giving you all some practice with solving equations, but also the inequalities and kind of setting them up. So let's try, somebody up for setting up B, C, and D. Make sure we get them set up correct. So B says more than 600 pads each week. Okay, so we want X to be more than, so not at least, more than, so it's a greater than 600. So for us, it's basically going to be set up the same, right? Except for it's going to be a strictly greater than, and the 600 is going to be here. So it's going to be 900 minus 300p greater than 600. And I'll let you all solve that for a minute. And then if there's other ones you want me to cover, please put them in the chat. We're gonna, again, the cool thing is the steps we did up here are gonna be the steps we're gonna do again. So subtracting 900, dividing by a negative 300. And because we divided by a negative, we have to flip the sign. So they have to keep the price less than $1. They must keep the price less than $1 to sell more, not at least, but more than 600 pads. I think that's per week, right? They said, yep, pads each week. And my folks, I can see Danielle, my folks that I can't see, which is okay if you don't have your camera on, can you at least let me know if you're doing okay? Give me a thumbs up, tell me to slow down. And whatever symbol, message me. I just want to make sure I'm giving you support. Is this helping? It's okay to say no, you need me to do something else. Okay, so you don't mind if I finish this one problem here, Heather? So 31C. So 31C says they want this to be fewer than 525 pads per week. So they're happy not selling pads, I guess. So they, we have the equation equals pads equals 900 minus $3,300 times the dollars per pad. And they want X to be fewer than, so strictly less than 525. Okay, so that means I'm going to put 900 minus 300p less than 525. So, and you can see because what they're, this negative 300 on the price per pad tells us, which we're going to learn more in chapter 3, but it tells us that as we raise the price, it's going to go down, the number of pads we're going to sell, which makes sense, right? The more they charge me, like, hello, the dollar store, Dollar Tree just went up to $1.25 on everything. I'm super sad. I should have went and bought them out of everything I love there. Anywho. Okay, so the cool thing is we're going to do the same exact steps that we've done because we're still just solving for P. And that's going to be a negative 375. 900 minus 525. And then we're still dividing by a negative 300. And because we divided by a negative, we still have to flip the sign. So P is going to be greater than or equal to $1.25. So if they charge more than $1.25, they will sell less than 525 pads each week. So real quick before I answer Heather's question on 2.7, I'm going to go back to 9 because everybody has this clear. So we know that here it's the cartridges is this many dollars, right? Based on this many dollars. And it says we want to sell at least 400. So we want our cartridges to be at least 400. So we want our equation to be greater than or equal to 400. So we're going to write it like this. 1300 minus 100p is greater than or equal to 400. I didn't have my bearings on how I wanted to think about these. On number 9, because we want X, we want to sell at least 400. We want to sell greater than or equal to 400. And so I'm going to set my inequality up. We know that X can be made by this recipe here, 1300 minus 100p. That's how I think about that. That's the recipe for X, and we want that to be bigger than or equal to 400. So you'll be good to solve for that. Let me go back and do letter D on 31 in a minute. I can, but I'm going to try to answer Heather's 2.7 question. Is Heather still here? Heather, what's your 2.7 question, hon? Or does anybody else have any questions? So 2.6 and 2.7 are all about the absolute value and the inequalities. So how about we that's where I did the number 70, the wavelengths of light. I thought that was cool. If anybody watched my video, I thought this one was really cool, where you could use this equation and it's based on the wavelength, and then it tells you what color it's going to come out to be when the sun passes through a prism. It's pretty cool. So how about we do a couple of these in 2.7 that I haven't done. I'm not sure what Heather's question is. I just want to make sure I'm not redoing any that we've already done. On 2.7. So 40, 40, 40, 40, 40. Okay. How about we do 57 and 60, that'll give us some more practice. So 57 and 60 on page 179 here. So 57. So 57 says the absolute value of 4 minus 3x over 2 greater than or equal to 1. So let's go back to our rules. They taught us 2 rules at the beginning of the lesson I wanted to remind everybody about. And the basic 2 rules, if you're doing a less than or greater than, and it applies for the equal to as well. So if it's a less than, it's going to be in between the negative and the positive. If it's greater than, it's going to be less than the negative or greater than the positive. So we have a greater than. So our absolute value piece is going to be less than the negative or greater than the positive. So we're going to have 2 situations. We're going to have 4 minus 3x over 2 is going to be less than or equal to negative of 1. And then 4 minus 3x over 2 is going to be greater than or equal to the positive 1. So less than or equal to the negative, greater than or equal to the positive. The question is number 6 on the worksheet. I feel like that is a goofy question. My question is, if I have on number 6 on the worksheet, yes. If you have a -2 over a -3, it works out to be 2/3. You can check your answers. So if you put a negative, go to Desmos and put 2/3 in, you should be able to see if that is correct. On 2.7, on number 6, and I can tell you that 2/3 is not correct, but I want you to go back and check that and see what questions you have. And then please make sure you watch the video when you're done with your appointment so that you get your questions answered on such a question so that we can make sure that you get that correctly. So your number 6 should be set up like this because it's a greater than situation. So is everybody ready to roll on 57? So anybody want to tell me what's the first thing that we should do? Yes, everything is on Canvas. So there are due dates for all of the assignments. They should be out there, 2/5, 2/6, 2/7. The due dates for all of those, 2/3, 2/2, 2/3, 2/4 should have all been turned in Canvas because we're not there. You can't drop them off at the school. So they should all be scanned in and put in Canvas. And then everybody should be planning to be in person next Thursday for the exam. Either way, we're in person. We should be doing our best to scheduling work and scheduling appointments around class. I know that we can't control that, but for everything, but we should be doing our best.
Do you want us to scan in like everything I did from YouTube last night, like the lesson 2.5 through?
You don't have to scan in. I don't need to see that you're doing watching the videos. I'll be able to tell. I mean, if people are asking the same questions that were asked that I did on the videos, it's, but I don't mind going through some of them, similar ones again, but I don't need to see that you're watching the videos, hon. But I just need you to scan in your assignment, those worksheets on the problems that I assigned, you'll be scanning those in.
Okay.
Yeah.
Thank you.
You're welcome, hon. Okay, so first thing we need to do is I want to eliminate that fraction because those drive me crazy. The cool thing is we only have one denominator, so I don't have to worry about what I'm going to multiply through by. I'm going to multiply through by 2 on both sides. Make sure you do that because we want that 2 to cancel out. the 2 doesn't do anything to the inequality. So we have 4 minus 3x less than or equal to a negative 2. Lucky for Mrs. Main, x is already on the left, so I'm cool with that. So I'm going to move my constants to the right by, it was a positive 4, so I'm going to subtract 4 because I want those to add to 0. So we have a negative 3x less than or equal to a negative 6. We're dividing by a negative 3. And because I'm dividing by a negative, I'm going to circle that, and it should be switched to a less than or equal, I'm sorry, greater than or equal to. The less than or equal to should be switched to a greater than or equal to. So x is greater than or equal to a negative 6 divided by negative 3 will be a positive 2. Okay, are you with me on that? Then on the right hand side, we're going to do similar solving steps. It's a different inequality. So we're going to multiply through by 2. That cancels. And we have 4 minus 3x greater than or equal to 2. Again, subtracting 4. So minus 3x is greater than or equal to a negative 2. And I'm going to divide by a negative 3. And x is, again, we've got to flip the symbol, so it should be less than or equal to. So a negative 2 divided by a negative 3 will give us a positive 2/3. And so that's weird because Heather was asking about a 2/3, and this answer is a 2/3, which is weird, not the one that she was asking about. But that is kind of weird. So they didn't ask us to do the number line or the interval, but let's just do that just so we're continuing to get practice giving our answers that way. I'll do the number line. There's my 0. Both of my boundaries are above 0, right? So I have a 2/3. That's going to be closer to 1. And then I have a 2. They're greater than or equal to and less than or equal to. So they both get a colored in circle. Let me do that with my different markers. So a colored in circle for both. And it's x is greater than or equal to 2. So I'm going to shade to the right on x here. And then the other one is x is less than or equal to 2/3. So that means I'm going to shade to the left.
You guys, please stop.
Poor things. You can mute yourself there. I totally get it.
I got 3 kids in the living room going, meow, my cat.
Oh, I remember those days, except for we didn't have this whole Zoom thing. So it was like, can't make it to work. Sorry. Can't make it to class. Okay, so let's do our interval for these. So we're going to have 2 intervals, right? And then we're going to have a big union sign in between them because we have an interval on the left. And so again, our interval is always our minimum value on the left. And in this case, there's no limit on my minimum value. So it's a negative infinity and it gets an open parenthesis. And then my maximum value is on the right, and that's the 2/3. And I colored it in because it's a less than or equal to, so it gets a bracket. So it has an equal to, and it's included, it gets a bracket. We're going to union that with the interval on the right. And my minimum value on the right is the 2. And I love it because when I do the number line, it visually kind of helps me lay out my interval. That's what I like about doing the number line first. And I'm including my 2 there. And then I have no limit on how big X can be. So that's a positive infinity on the right with a parenthesis. So everyone's paper should look like mine. Also, a reminder when you're watching the videos from the YouTube videos for the lessons, write out every problem like I'm doing, because I want to make sure that you're able to follow along. Not like my method is the right method, but it forces you to write out every step. Now, if you're getting it and then you start doing your own homework and you're like, I don't need to write out every step or whatever, that's fine. But I want you to practice thinking through every step on the way you're doing the problems. Anybody have any questions so far? Sure, Danielle, you have a question?
Are we gonna have to use like Desmos when we do our test Thursday? Because I haven't used it at all yet, so I'm kind of like, I don't know what to do.
I don't think you're gonna need it unless you want to be able to practice with it. I was kind of actually just thinking about doing an assignment in 084 where everybody shows me how they can check their answer. But I guess if you could check your answer on paper, that's fine too.
Okay.
I'm just trying to encourage everybody to use Desmos, because if you have to take Math 151, Desmos is the quicker you learn how to use Desmos and let it help you check your answers and see things, it is going to make 151 even more easier, not more easier, but like less of a struggle, just because you're gonna like feel comfortable checking answers and seeing things on Desmos. That's why I'm challenging you to do it. So I'm not requiring.
Okay,
So you don't need it for the test. If you can do everything by, on your paper with a calculator, I'd recommend a good graphing calculator, because I won't let you use a cell phone for a calculator. So you'll need to, I have some calculators I can share with folks too. Or if you take it in the testing center, that's fine. I think they have calculators you can use.
Okay, thank you.
So let's do number 60. I am going to pause the recording so that folks can kind of get it set up and work on it, and then we will do it together. So this one says 4x minus 3 over 2 is less than or equal to 1/3.
You're muted.
Got it? So because this number 60 here, because this is a less than, the absolute value is less than 1/3, it's going to be between. So it's going to be between a negative 1/3 less than or equal to the 4x minus 3 over 2 less than or equal to the positive 1/3. Okay, so to figure out what you want to multiply through for your fraction, because when you get rid of the fraction, it does make the problem easier. You can take 3 times 2 in Desmos or in a calculator and see that that is 6. So if we multiply each side by 6, we can cancel out our fractions. So you can either cancel it. Oh, good question, Danielle.
Can you repeat all that? I did the whole problem and
But we're all
wrong. I'm sorry.
frozen.
Where are you getting 6 from?
Okay, I took my 2 and my 3 in my denominator and I multiplied them.
Okay.
So you're looking for basically, if you were going to just use the fractions, you would have to get a common denominator, right? And that would be 6. And so I'm going to multiply through by the common denominator instead, and that eliminates the fractions. So I'm going to do a little side note here, just for people that are still like trying to rationalize in their brain, why are we doing this? And it's okay, because that's how I was a student, like, why am I doing that? So let's just say we're baking for a minute, okay? Is everybody okay with baking? I think we all probably had baked or cooked something. And so I think baking kind of helps us relate a little bit. So right now we have the denominator of 3 and denominator of 2. So I'm going to say I'm baking something, and I'm baking something where I'm using 1/3 cups of something, right? And I'm using 1/2 cups of something. Okay. My recipe has 1/3 cup of something and 1/2 cup of something. But let's say I go to my drawer. Here's Mrs. Main in my drawer. And I'm like, oh my gosh, all I have are whole cups. I don't even have measuring cups today. They're all dirty. My kids used them. The 1/3 cup is dirty and the 1/2 cup is dirty. So I need to try to do something with this recipe, because all I can do is scoop out whole cups.
Yeah, the dishes.
Is everybody with me? All I have is a whole cup. So it's like, how many times could I do my recipe so that I can just use a whole cup? So how many times would I have to do this 1/3 cup recipe? So don't look at the 1/2 cup. How many times would I have to double, triple, quadruple my recipe to get a whole cup on this ingredient up here? We'll say this is the flour. Can anybody guess? How many times would I have to double, triple, 4 times, 5 times this recipe here so that I can just use a whole cup? So I'm gonna kind of test it out. So if I did 1/3, if I doubled it, it would only be 2/3 of a cup, right? So no. So what if I did it? So if I did 3 times my recipe, I would be able to use a whole cup, right? Because it'd be 1/3 plus 1/3 plus 1/3 would be a whole cup. Okay. So let's see if I can do that down here. So if I 3 times my recipe up here, I can use a whole cup, because that's all I've got clean in my drawer. So I'm going to triple this one. So if I do 1/2 plus 1/2 plus 1/2, oh shoot. If I would have stopped at 2, I would have had a 1 cup, right? But now I've got a 1.5 cups. So what if I can do this? How many more times can I get to the next cup? So if I go another one, now I'm at 2 cups. But if I did a 4th one of this, that's too much. Let's see if I do another 1/2 plus 1/2. So I've got 1 cup, 1 cup, 1 cup, right? So that means I have to do this one a total of 6 times. So I did this 1, 2, 3, 4, 5, 6, right? I 6 times my recipe. 3. And so if I 6 times this recipe, 1/3 plus 1/3 plus 1/3 is 1 cup, plus 1/3 plus 1/3 plus 1/3 is 2 cups. So if I do 1/3 times 6 here, I get 2 cups. So that means if I 6 times my recipe, I can use whole cups for flour. I would just need 2 whole cups. And if I 6 times my recipe for sugar, I could use whole cups. I would just have 3 of those whole cups, right? That's what we're doing here. That's why we're doing this. I don't know if that's going to help anybody at all, but that's that's multiplying through. So I'm just going to multiply these as fractions so that everyone can see. This is a -6/3 less than or equal to 4x. I'm going to multiply this through. So 6 times 4 is 24x minus 18/2 less than or equal to 6/3. Now, if you just cancel your 3 into your 6, and then your 2 into your 6, and your 3 into your 6, that's fine. I'm kind of going the long way so everybody can see how I got there. So -6 divided by 3 is the 2, less than or equal to. In the middle, 2 divides into 24, 12 times -18 divided by 2 is a -9. Okay. Less than or equal to 6 divided by 3 is 2. Oh, that's a -2 on the left. Okay, so now that we're here, now we can actually solve for x. So I'm going to circle x. And also, when I solve for equations, I think of weird things. They're not bad, like evil things. I'm just saying, I think of things in weird ways. I think of this as my kids when they were little. So this is probably how Danielle thinks today. Anything that's attached to x is clinging to x so tight. You cannot get rid of it till the very end of your solving. Okay. Whatever is attached to x is so tight. It's like your kids, you're like, come on, give me some space. Now, anything that's adding or subtracting, you can get away from them easier. Okay. So we're going to get rid of the -9. That's the first thing I can get rid of because it's not as attached to me. Okay. So I have to do the opposite thing to get rid of that -9 by adding 9. So I have to do that to all 3 pieces. So a -2 plus 9 is a 7. That adds to 0. So we have 7 is less than or equal to 12x is less than or equal to 2 plus 9 is 11. And yep, sure enough, that 12 hung on to the bitter end, right? And x is like, come on, I just want to be by myself. I need some peace and quiet. So 12x, x is going to divide by that 12 and divide by the 12 and divide by the 12. And they're fractions. You don't have to divide these with decimal. I'm fine with a fraction. So 7/12 is less than or equal to x, which is less than or equal to 11/12.
You guys.
And I'm going to do the number line and the interval just for practice. So they're less than or equal to, so that means my breakpoints are going to be colored in circles. And 7/12 and 11/12. And it's going to be shaded in between. And then this makes my interval really nice because they're both shaded in. So I'm going to have brackets around both. And so 7/12, comma 11/12. So hopefully this is helping the setting up, not just solving the absolute value, but solving equations in general, because it's forcing us to go through a lot of the similar steps. Shall we do one that's jazzing it up a little bit more? Or my live people get to decide here.
I'm still confused on the brackets.
Okay, so there's some questions over the brackets, the parentheses, that whole debacle on the interval solving. So let's just kind of go through and do some with that. Is that cool? So anytime it's a strictly greater than or a less than or greater than, it gets open parentheses. And on the number line, it gets open circle.
Okay, so if there's not a line under it, you said?
Yep. And so I think of it as my parentheses are a smooth curve and my open circle is a smooth circle. Those go together. And you can have this on your note sheet, right? For the exam. Anytime it's including with the equal sign underneath, it's brackets on either side and the values are shaded in. So I'll do a couple. And the other thing is the negative infinity always gets an open bracket and the positive infinity always gets an open bracket.
Repeat that again, please.
Okay, that makes way more sense.
The infinity symbols always get an open parenthesis.
Every time? Thank
Every
you.
time. So the only thing that gets a bracket is when it's included. Good, I'm glad that's helping, Sammy. So, so let's do one. Let's say X is less than a -2. So my number line, I like to do the number line first because I can go 0 and then I know a -2 is going to be somewhere over here. I'm not particular, as long as you kind of place it in a, you don't even have to put the 0, but for me, I like to do it for my brain. Okay, and then it's because this is strictly less than, it gets an open circle. And then because it's pointing to the left, X, and I always like to write my X on the left. So wherever, if X is on the left, if it's pointing left, then I'm going to shade left. Because X can be anything less than a -2. Okay, then that helps me with my interval because my interval is always the min it can be and the max it can be. Min on the left, max on the right. And so because the minimum it can be is no end, right? It's -infinity. It gets a parenthesis. But I do have a limit of how big it can be. And -2 is the biggest it can be, but it can never get to a -2 because it's a strictly less than, it gets a parenthesis. Are we good with that one so far? Okay, got a thumbs up from Sammy. Danielle, give me a thumbs up. Okay, so shall we do some equal and then I'll do a jazzed up one. Okay, so let's say we have X can be greater than or equal to a -1. I'm gonna draw my number line. I like to put 0 and -1 is to the left of 0. Because it's greater than or equal to, I'm going to put a colored in circle and X is on the left. So you can use, so if you write that down for yourself, if you always make sure your variable is on the left, wherever it's pointing to is where it's going to extend if it's not a double inequality. So X was on the left here and it's pointing to the left. So it's shaded to the left. X is on the left, so I can use my pointing. It's pointing to the right, so I'm going to shade to the right. Okay. Also, if you've noticed, the single inequalities always have an endless limit because it's a single inequality. It always has an endless limit either to the left or to the right. The double inequalities will have the endpoints, both endpoints. Okay, but these are single inequalities, so they always have an endless endpoint to either to the right or to the left. And so now that I've got this set up, I've got my min and my max. This time my minimum value is a -1, and I get to use a bracket because it's including it. It's got an equal sign, and I'm endless to the right, so it's a positive infinity with a parenthesis. Okay. Everybody with me so far? Okay, shall we do one with 2 endpoints? So let's say X is between 3 and 7. Now, X is greater than or equal to 3, but it's less than or equal to 7. Okay, so because it's between them and 3 is less than 7, then 3 is going to be on the left, 7 is going to be on the right, and they happen to both have equals, so I'm going to shade them, and then I'm going to shade in between. And so my interval is going to be a bracket on the 3, comma, 7, and a bracket on the 7. Everybody with me so far? Okay, is that helping on the inequalities and the intervals and the number line situation?
Yes.
Yay.
With her when I wasn't here. And I don't think that's right at all.
Okay, so there's a question on, just a minute. You can do it like that, but there's no reason why they couldn't be together, because on number 4, it is less than 3 and it can be greater than 5, right? So they could be in the same line.
So, okay, because I feel like I've been putting 2 lines on all these, so I don't,
On the
Okay.
ors,
on all the ones I have to graph, I've been doing,
what
like-
about number 4? Did you do an and it has to be on the same because it's and it has to be greater than this and less than the other thing.
huh?
Okay, so what ones did I assign here? 2, 4,
1 through 5.
on 2.5?
Oh, no, I'm confused. Which one are you talking about?
You were asking on 2.5, I thought.
Yeah, for number 1. It all just goes on one line.
But in number 1, I let me see on 2.5. I didn't think I assigned number 1.
I don't think you assigned any of them yet.
Well, they weren't showing up. Well, they
I
were
see, I don't-
they were there, they just weren't showing up. That's my mistake. So I have 2, 4,
Oh.
and I don't know why I only had just a minute.
I have a quick question.
Is that what I had on 6 too? You had a question, hon?
Yeah, like, so you said we can use our notes. Is that all we can use, or could we use this worksheet too?
No, you have to contain it to
Just
the
the
exam
notes?
is one sheet, double-sided formulas, examples, whatever on one sheet. Otherwise, people will take hours because you're gonna rifle through all your notes. You're gonna try to find that one example that's just like the test problem. It does not serve you well.
So
So
is
Yeah,
it just one sheet of line paper front and back?
or a blank paper, but yeah, front and back, 8.5 by 11. Yep.
Okay, thank you.
Mhm. So 2.7 is all of that worksheet. And then, okay, let me go back and record this. So, okay, so we're gonna do some more. So 2 and 4 are assigned. So we're gonna do some more for examples on the worksheet. So this is number 3 on the worksheet for 2.5. Okay, so this is an or, so I'm gonna mark my boundaries in -3 and 2. And because X is greater than or equal to a -3, and it's shaded in, it's gonna shade this way. Or X is less than 2, so I'm gonna shade to the left. And so that means it has to be, I'm shading completely to the right for this one, and then 2 gets an open circle and I'm gonna completely shade that way. So the only thing is that because they're both shaded in both directions, this is one big shaded in number line, right?
Is it gonna be, sorry,
No, go
is it gonna
ahead.
be like that every time that there's arrows facing both ways?
So on to be honest, this is weird. Like, it's rare that we would ever solve an equation where it's ends up being all values, because this one ends up being all values. It just happens to be it's greater than the negative and less than the positive. So it completely covers the negative infinity to positive infinity. Usually it's going to be this. If it's an or, they're going to go in opposite directions. If it's an and, it's going to be in between.
Okay, thank you.
Okay. So, but let's look at number 5, because I didn't look at this one yet. And so maybe they did some weird stuff at number 3. So maybe they did some weird stuff at number 5.
We're on 2.5, right?
Yes, ma'am.
Okay, I did 2. Like, could we go over that to see if I like did it right?
Okay, what are you thinking? Mm-hmm.
Well, can I just like show you a picture?
So
Hold on, I gotta go to my settings again.
you can see on number 2 that it's greater than a -3 or it's greater than 2, right? So if you shade them in different colors, you'll see that there's some overlapping. Yes, 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 you're right. So Sammy's working on sharing her screen here, or turning on her camera. So I'm gonna go ahead and look at number 5. She's coming back on something else. So number 5 says x is less than a -2. So I'm gonna mark a -2, and it's strictly less than, so it gets an open circle. Just a minute, hon. It gets an open circle, and I'm gonna shade to the left. And then in a different color, I'm gonna do this one just so I can kind of see it, if they overlap. And then my other boundary is 3, which is to the right, and it gets an open circle, and it says x is less than that one, so I'm shading to the left. So it really looks like it's all less than 3, right? Because they kind of overlapped. So on this one, it's x has to be less than a -2 and less than 3. So only the part that is overlapping works. Only the overlap. So that would be a negative infinity up to the -2 with a parenthesis, because they were both strictly less than. So you wanted to go talk through number 2, Sammy?
Yeah. So hold on if I can.
So a reminder, an or means either solution, everything's included on either solution, and means it's only where they overlap. Okay, only where they overlap. So let's look at 6. So x is less than a -2, which is similar to number 5, right? So an open circle, shade to the left, and x is greater than 3, so open circle and shade to the right, and it's an and. So is there any and? Is there any overlap?
There's no overlap.
Yeah, so there's no overlap. So there's really no solution. Because x cannot be less than -2 and bigger than 3 at the same time. It's just not possible.
I feel like I understand that now, how to do that.
Awesome, awesome, awesome.
I feel like I'm still not understanding the infinity symbol or why I'm using it or when I'm supposed to use it or what it's for.
Infinity means when it's going off and forever and I don't have a boundary. So for instance, here, x is less than or equal to a -3. Well, -10 is less than a -3, right? A -100 is a less than a -3. A A -1 million is less than a -3. A -1 trillion is less than a -3. I don't have a limit of how negative I can be. So I have to use a infinity symbol.
But how do you know if it's, oh, because then, oh, never mind, I get it, never
Because
mind.
it's shaded in equals. Now on the 2 is the smallest this one can be, but it gets a parenthesis because it's a greater, strictly greater than. And then it says X is greater than 2. So 5 is greater than 2, 100 is greater than 2, a million is greater than 2,
So that's
3
where the
trillion.
infinity- Okay.
So it's an infinity. And it gets a big union symbol here. We're unioning these because OR is a union of all solutions that satisfy both. OR means all solutions that satisfy both because it's OR. X can be this or X can be that. But when it's an and, it has to satisfy both. Only what satisfies both.
Okay, but so for 4, I got an overlapping again. It'd only be one answer, right?
What?
For 4, I got an overlap again. It'd only be one answer, right?
X has to be greater than a -2 and X is less than 3.
But they both overlap each other.
Right. So they overlap only in between there, right?
Yeah.
Yep. Good job.
So it'd only be one answer then, right?
Yep.
So -2, comma, plus infinity.
Mm-hmm.
Okay, sweet.
Well, -2 up to 3, right?
Oh,
Because X
because
has to be
that's the
less than 3.
maximum. That's the maximum.
It's like did you watch the videos? I did several on the videos.
No, I didn't watch the videos.
Yeah, you'll want to go. That's what is important, that you're watching the videos.
Okay. I watched the first 3, but I didn't watch the ones I was supposed to watch last night, like 2.5 through 7, 2.7.
Yep. So I'm just recommendation for everybody on the call. And that's good. I'd rather have honesty, right? Best policy. So
Yeah.
I can promise students it's going to be like, oh, it's kind of like frustrating that I have to spend time before class to, take time to watch videos. But 1, we're hybrid, so you are expected to do extra work outside of class. And 2,
Yeah.
I can promise everybody this because I did this at my old school. My students, when they watched the videos before coming to class, their brain was already engaging in the activity. And then when we got to class, they were ready to ask good questions like, I watched the video and this is where I'm stuck. Or I watched the video, I'm following along and I'm trying the problems now and this is where I'm getting stuck. So that's the idea is after the exam next week, I will have videos for 3-1, 3-2, 3-3 or whatever, and you'll watch those before you come to class the next Thursday so that we can engage in and work on, these problems that are assigned in class. That will definitely help. And by all means, I'll be doing more examples in class, but it'll build on your understanding instead of being the first aha of your understanding, if that makes sense.
Yeah. I'll definitely
Good.
watch them.
And also both classes, all my students, I want you to all know my 084 students already know this, but if you go to click on my YouTube link for any videos, you can see every video I have on YouTube, so you can see stuff from my old school. I don't really care, but if you go to the 084, that's where you're going to see more support videos. So there's always going to be extra videos of things to watch out there. You can find other people that you like learning from better than myself. I'm totally not offended. And if there's new things that you want on videos, send me an email. If you want to set up individual time for Zoom sessions for help, send me an email or send me a remind text message. I'm happy to set those up. I've got time allocated for everyone, and I can Saturday mornings are usually a pretty good time for me. Sundays I don't like to meet because it's kind of my one day. I totally allocate for family, but I've got time Monday, Wednesday as well.
Okay.